C-band transponders, extended C-band. Okay. So, C-band, this is for I will say cable TV downloading from the satellite. Your cable TV fellow will be downloading in extended C-band, sorry, in C-band, and then from the cable TV's head office to your house, it may be in VHF and UHF. Okay. VHF and UHF is from on a cable, when it comes, it is in that frequency only, it is further less anyway. So, C-band, your satellite TV, satellite TV means the all these ZTV or Star TV, all the normal TV channels which you receive by a cable, that is C-band. Extended C-band is especially for VSAT, for other dedicated communication. VSATs have even earlier, please remember your ATM. These days in the cities, ATMs are connected by cable, but even today a remote village, if there is an ATM machine and above the building of the ATM machine, see, when you go inside the ATM counter, when you put your card inside, how do, and immediately they will ask for PIN bhi de diya, immediately balance enquiry. How do your machine, when you put the inserted your card and you gave the PIN, how do this machine, this ATM machine, how come it come to know that there is no balance in your account, when balance enquiry is 0 or 10 rupees or 9 rupees if it is showing, how do this machine know that you have no money? What is the mechanism? Normally this ATM machine above the building, there could be a dish, if it is a remote place. This dish will communicate it to the satellite and the satellite immediately, that signal will be downlinked to a hub. Hub means a master control room or a control room where all the signals will go, and from the hub, suppose you have a bank account in a South Indian, sorry, in State Bank of India, SBI, and you put the ATM machine in Calcutta, your account is in, say, in Chennai, hub may be in Hyderabad, we do not know. So, from the hub it will redirect the signal to, say I will let me draw it again, let us avoid the confusion. So, ATM, say at Calcutta, signal going to satellite, satellite will download to the hub, hub may be in Hyderabad, hub means the master control room. From the hub, once again it will send the signal back to satellite and to the your bank, say in Chennai or wherever the bank's main server is located, bank main server, if it is in Chennai or in Pune or in Bombay, wherever it is, say SBI main server, if it is in Chennai, it will go to Chennai, and from the main server, since your the debit card as well as the PIN is given, so it will verify your account where the data is stored in the server, and the server will send back the signal to the satellite, satellite can again download to the hub, hub will again send back to the satellite and it will come to the ATM machine. So, multiple times communication has gone from the ATM to satellite, satellite to hub, hub back to satellite and then to your server in Chennai and back. So, this kind of a star typology, connectivity is like a star, go up, down, again up, down. Okay. So, this kind of a communication like a star. So, then the ATM machine will give you the, on the screen it will come how much money is there, how much money is left in your account. So, when you insert the card and the PIN number, message has gone to the satellite, from the satellite it has been downloaded at the hub where it is called the master control room of the satellite. Then there it is reallocated to wherever the server is located, and from the server you will get the information, and finally it is came to know that whether you have any money in the account or not, or anything left in the account or not. Okay. So, this kind of a connectivity is possible from a remote place anywhere. It is through VSAT. So, VSATs have great function, or other remote that financial inclusion is possible. Even today, most of the facilities in the villages or far away cities, in the metropolitan cities like Delhi, Calcutta, Mumbai and all, it may be, or Chennai or Hyderabad or Bangalore, it may be through cable network. Your an ATM machine may be connected through cable network, but mostly it may be connected through VSATs. So, VSATs play a very crucial role in the the financial inclusion, dedicated communication, but in all these cases what we are using is X-C-band transfer. See, please remember, when you go to an ATM machine, have you ever seen any ATM machine buffering? Have you ever seen that please wait, I am collecting data? Kuch nahi. Initially when you put in the data, they may ask you to wait for 10 seconds or something. That is the time when the connectivity through satellite has to be achieved. Once it is achieved, it is instantaneous, there is no delay. By the time you key in the PIN, automatically it goes. Why? Because it is connected through satellite. Okay. X-C-band transponders are used here, and in the X-C-band transponders, please remember the wavelength is between 3.8 centimeters to 2.5 centimeters, and the frequency is 8 to 12 gigahertz. That is X-C-band transponders for our VSATs and other things. But our DTH, okay, forget about this, let us come to our DTH, direct to home TV, your Dish TV or Tata Sky, Jingalala. From where is that? So, that is by using another transponder called KU band transponder. Okay. Whether it is the DTH, direct to home TV, our Dish TV or Tata Sky, or what you call a Videocon. So, there are a series of service providers there. KU band transponders are used there, and KU band transponders have 2.5 centimeter to 1.7 centimeters as the wavelength and 12 to 18 gigahertz as frequency. Direct to home TV and digital quality, digital picture, digital TV, direct to home TV, HD channels, are mainly through KU band transponders, that is between 12 to 18 gigahertz. If you need further high quality, then we have even KA band transponders. KA band, it is somewhere between 27 to 40, that means 1.1 centimeter to 0.75 centimeters, 27 to 40 gigahertz, and this is where we can use it for internet connectivity. Broadband, connectivity through TV, through satellite, KA band transponders. Okay. So, in between KU and KA, there is a K band also. I was not talking because KA is mainly for broadband connectivity. Then there are also, I am not detailing all, उसके बाद we have V band, then W band, and finally millimeter waves, where 0.27 centimeter to 0.1 centimeter. Point 0.1 centimeter means 1 millimeter. And this millimeter waves, please remember, in 5G technology and all, we are using millimeter waves. The wavelength is 0.27 to 0.1. 0.1 centimeter is 1 millimeter. 5G technology may be working in that, the radio signal in millimeter wave, or the frequency. The frequency is 110 to 300 gigahertz. Very high frequency. See, please remember, more the frequency, more energy. More the frequency, more energy. A millimeter wave means very high frequency. Frequency anywhere between 110 gigahertz to 300 gigahertz. 110 to 300. Very, very high frequency. Millimeter wave. So, in 5G, I already told 5G technology and all, which is millimeter waves are used in 5G anyway. Here, you please remember KU band for dish TV, KA band for broadband. We are already using KA band, transponders in some of the latest GSATs. We are doing it, and 5G technology and all will come. So this is how the the bandwidths. Okay, the radio frequency letter or band nomenclature, the standard. Okay, this is the band nomenclature. So this is the band. Band nomenclature. Okay. So anyway, so in our concern, so we we started with S band, of course, low quality, then C band where the cable TV finally coming to your home, XC band for VSAT and dedicated communication, our ATM machines all work under the XC band, KU band for DTH, KA band for our internet connectivity, broadband connectivity through satellite if it is coming, then V band, W band, and then finally the millimeter waves like 110 to 300 gigahertz or 5G, the 1 millimeter wave. So anyway, have some idea. So that is how it is being located. Okay. Now VHRR, a couple of points. Very high resolution radio meter. So this VHRR, okay, VHRR is the weather forecasting instrument. and normally it provides visible and infrared imageries with a resolution of 2 to 8 kilometers every half an hour. So, this is an image, basically photography. VHRR also takes in visible and infrared imagery with a resolution of 2 to 8 kilometers every half an hour. See, please remember when you used to watch Doordarshan and all, there used to be end of every news bulletin, there used to be an India's photograph and some cloud cover here and there. I don't know whether you remember that in Doordarshan. So, that used to be, they used to say according to INSAT picture, they used to say INSAT picture, it is like this. According to INSAT picture, this is like this. So, this INSAT picture is nothing but a VHRR picture. It is a visible and infrared imagery. The visible and infrared image, resolution of 2 to 8 kilometers, which is taken every half an hour by the inside. So, that on top of, see, suppose an India map, and on top of it if they are showing some cloud here and there, okay, imagine they are showing some cloud cover here. So, that photograph was taken by the INSAT. Okay. Please remember that cloud cover photographs, and these images are used to determine the cloud. It will help in understanding, this VHRR pictures will help in understanding the cloud top temperature, the temperature of the top of the cloud, also the cloud conditions, the amount of water vapor in the atmosphere, also the wind speed, direction. So, all these things will be given by this VHRR. It will help in predicting. So, on a day to day basis, weather forecasting, that or even an hourly, half an hour basis, the weather forecasting is possible with the help of these pictures. So, the very high resolution and for meteorology application, these VHRRs are very important for day to day, hourly basis or half hourly basis weather forecasting. Okay. So, that is what is done through VHRR, very important for our purpose, right. So, I was talking about transponders, then I talked about the VHRR, that is for the weather forecasting. Now, as far as the latest communication satellites are concerned, latest communication satellites by India. The latest one which we have launched is called CMS-1. Okay. It was supposed to be earlier, the nomenclature was GSAT 12R, but now they have changed it. GSAT naming also has been, I think, discontinued right now. Communication satellite. So, that is what we are understanding, but even CMS full form itself has not been clearly given anywhere. I have not seen. If you have seen somewhere, please let me know. we have understanding that it is a communication satellite. So, it is by launch, it is in December 2020, and it has replaced the GSAT 12. So, this was launched by a PSLV C50 launch vehicle or a rocket. Okay. PSLV C50, I will just come to that, PSLV C50, and this is mainly, it has extended C band, X C band transponders are there. Okay. This is X C band, एक second. It is the mass is just 1425, 1425 kilograms. Weight. PSLV 350 has launched it. Now, please remember, I said PSLV, Polar Satellite Launch Vehicle. So, that is mainly for our, that is how the PSLV word has come. Now, let me just clarify this point, because otherwise you will get confused, why, then how are we talking about. So, this normally PSLVs are launched or Earth, PSLVs are used for launching satellites revolving round the Earth from pole to pole. Normally. So, the PSLV capacity is also like that only, and it is in a near or low Earth orbit in a LEO, and normally PSLVs can launch up to around 2000 kilograms up to around 1200 kilometers. And please remember, if the height is less, then the weight, the payload can be increased. But please remember, the same PSLV can also be used for launching small geostationary satellites also. Please note, the same PSLV can also be used to launch small geostationary satellites. Small means up to 1500 kilograms. So, in that what happens is, the same satellite can also be used for launching it such a way that it may be taken in a highly elliptical orbit above equator. A highly elliptical orbit. So, they can be used to launch a small satellite into a GTO. I already said geostationary transfer orbit. So, PSLVs can also be used to launch small geostationary satellites up to 1500 kilograms into a GTO. Okay. into a GTO or geostationary transfer orbit. But it cannot launch large satellites, huge ones, 3000 kilogram, 3500 kilogram, 5000 kilogram satellites we cannot launch. Up to 1500 kilograms can be used, PSLV also can launch, but our communication satellites, most of them, whether it is INSAT, GSATs, they are all heavy ones. But in emergency we can also use for launching smaller ones up to 1500 kilograms. So, after getting launched into this kind of an highly elliptical orbit GTO, see through on orbit, within the satellite itself we have small motors, okay. Within satellite there are small rockets and some fuel, liquid fuel again given, so that we can give command which we call on orbit maneuvering, on orbit maneuvering. Okay, this can be used for on orbit maneuvering, and using the firing these smaller rockets within the satellite, we can raise the orbit. We can raise the orbit and bring these satellites into a geostationary orbit. So, from GTO using on orbit maneuvering, these satellites can be raised to a fully circular geostationary orbit. Okay, it can be raised into a fully circular geostationary orbit. So, what is happening? A PSLV can also be used for, see normally PSLV word itself has come for launching it in the in a polar sun synchronous orbit, but this can also be used for launching smaller satellites into geostationary transfer orbit, and from there using the on board rockets, okay, using small rockets and fuel in the within the satellite, which we call it as the on board rockets, using on board rockets we can raise the orbit on board or on orbit maneuvering, we can raise the orbit to a geostationary one. So, that is how PSLV, now coming back to our discussion, PSLV C50 was used to launch the latest communication satellite of India in December 2020, but it is a small one, 1425 kilograms only. I already told PSLV have no capacity beyond 1500 kilograms for launching it to a geostationary orbit. So, that is how PSLV is a CMS-1 was launched. Before that we have launched GSAT 30. Before that we have launched GSAT 30 was launched in January 2020, and we have used Ariane 5, European Space Agency. Okay. It was 3350 kilogram. kilogram, and we have launched 12 Ku band transponders and 12 C band transponders. So, it was an exclusive communication satellite, no weather forecasting payload, okay. And this has actually GSAT 30 was to replace, just to have an idea, INSAT 4A, INSAT 4A which was launched in early 2000s, we have replaced INSAT 4A, and since the C-band transponders are there, in some places even that VSAT network also useful, but mainly for DTH, okay, television, digital satellite news gathering, etc., etc. Okay. So, that was done by the GSAT 30, Ariane 5, okay. And please remember, this European Space Agency, they are launching it from the French Guiana or from Kourou, the place from where European Space Agency launches in French Guiana in South America. So,